Morning, everyone. How are we all doing? That was really weak sauce. Come on, guys. Once more. How are we doing? All right, that sounds much better. Okay, so my name is Alex Liu, and I currently work at Netflix. I'm part of the core team that's helping to migrate our Netflix.com to our new Node.js stack. And today, pretty excited to share with everyone some of the cool stuff we've been doing in Node. So to give a little bit of background, at Netflix we do a ton of A/B testing. And we use all this data gathered from our tests to figure out how to build an even better experience for our users. And when I say we A/B test, we really do A/B test everything. Everything from our sign-up flow to our member homepage. And there's probably not a single element on this page that hasn't been tested and retested many times. And we also have some tests that allow us to do revolution instead of evolution. The recently launched profiles feature is a great example of that. We implemented the profiles test across multiple platforms, which involved a lot of coordination between our UI teams and our data services teams. So when people think of A/B testing, they typically think of one or two variations of a single experience. But here at Netflix, we do multivariate A/B testing, where each test has multiple cells, each with a slightly different experience. And not only do we have multiple variations of a single test, we also run multiple tests at the same time. So test allocations are done pretty randomly, so users get experiences that are unique to their combination of test cells and allocations. So one thing to note here is that not all customers get allocated to all tests, and the users' allocations can and will vary quite widely. So if everyone remembers their math, and we were to pick one of these experiences from each test, and we calculate the total possible number of unique experiences, we'd get something like 2 million unique experiences across just these 7 tests. So you might think that's a pretty huge number, but the reality is that we actually run hundreds of tests every year. So imagine multiplying that matrix you just saw by about a factor of 100, and you'd end up with a ridiculous number of unique experiences that look something like this. It's so big it doesn't even fit on the slide, and even if it did, I would have no idea how to say it. And this is what that complexity distills down into, right? This is the number of files that we have for each type of UI asset in our code base. Pretty crazy, right? And these numbers are so big because they represent all the different experiences you could get on the website. So if we dig out our math skills again here and say the typical JavaScript and CSS package for our website contains somewhere between, let's say, 30 to 50 files, what that means is that in practical terms, it means we're generating about 2.5 million unique packages every push cycle. It's a staggeringly large number, and yes, it is real. This number will only continue to grow as we do more A/B testing. And so at this point, the problem of scale becomes quite clear, right? How do you even begin to manage your packaging at this kind of scale? And that's a great question because that's exactly the problem we're trying to solve. Since we do a massive amount of A/B testing, we need to find a way to quickly determine not just the unique experience that the user should receive, but then we need to actually serve it out to them. And so what it boils down to really then is a problem of being able to resolve conditional dependencies in a performant and maintainable manner. So let's explore how this all kind of breaks down. Let's say today that we are A/B testing search. So see our little search box up here in the upper right-hand corner. And like all web pages, we need to send a JavaScript package down to the user. So here we've got our top-level app.js file, and we have our 2 search experiences. So we've got old search or control search, and then the new experience which we are testing here, new search. So ideally, if you are in the old search experience, you should only get the dependencies required to make old search run. And likewise, if you're in the new search experience, you should only get the new search dependencies. So here's what that kind of looks like in the code. We've declared our hard dependencies here, old search, new search, and of course, ever-present jQuery. And import statements like this are great on the server, right? You pretty much import the entire world as necessary, even though you might only execute one of those code paths. But for client-side JavaScript, it's not as straightforward, right? Let's take a look at why. So a common strategy is to simply bundle all of your possible dependencies and send them down. So if anybody has used RJS Optimizer or Browserify or any of those other build time solutions, this is probably what you're doing. But there's a problem for us in this scenario, right? If you remember, we have a ridiculously large repository. So if you bundle and send everything down, we're looking at what, was it 700 something files? And then 2.5 million packages, right? And these numbers are growing, so this is not really a business we want to get into of pre-generating these packages. So this is not really a solution that works for us. So I see some of you are probably thinking like, all right, well, why don't you just request your stuff asynchronously? Okay, so the user comes in, asks for app.js, and then say at this point that we've pushed some of that context down to the browser, right? So the browser knows how to resolve the conditions here. So let's say we determine the user is in the old search experience. So we'll go and get old search, which will go and get dependencies and sub-dependencies and so on and so forth. So off the bat, you'll kind of see right away that this is requiring a lot of serial requests, right? And it might be a really good idea to do this for leaf nodes, but it's not so great for the core package, right? Especially here, we're talking about search. Our users love to search, and we want that to be available on the page as soon as possible. So I think it's worth re-emphasizing the problem here, which is that we have conditional dependencies. And what we really want to be able to do is to build a package specifically tailored for a user based on their AB allocations with a minimum amount of fuss. And we want to be able to do it so in a way that doesn't force them to download files they don't need, but also doesn't force them to wait to get the files that they do need. So what it would look like is the user comes to the site, we give them a package, and it has just the files they need, no more and no less. So most of the solutions attempt to sort of tackle this problem from a purely client-side perspective, right? But we thought pretty hard about this and we realized something. We've got this thing called a server. It has all the context that's needed to resolve these conditional dependencies. Why don't we have it make it do some work? And so ultimately, we found two places where we could do this work. One at build time using static analysis, and the second at request time when we actually generate the response for this page. And it turns out that's all we really needed. Using just these two hooks, we could actually build a small collection of NPM modules to help us solve this problem. So the first of our modules is called NF include when. This module aims to solve the most basic question. How do we know when a module is conditional? Well, modules that are conditional can mark themselves as conditional using an annotation. Can you guys see that? It's pretty light. So it's basically a comment that's got a @include_when and a string associated with that. So what's happening here is that old search is basically saying that I should only be included as part of your package when the rule for not in new search resolves to true. And for new search, it's got a rule too, and says I should only be included in this package when I am in the new search experience. And this is nice, right? Because the code becomes a source of truth. So here's what that rule actually looks like. It's fairly straightforward. All it really is a function that resolves to a Boolean value. So you could pretty much do conceivably anything you wanted to inside this function. Second module here is our asset registry. So this module does a bunch of work at build time. Let's take a look at what it's doing. So if you remember the signature here for our app.js file, well, it turns out we can do static analysis of this at build time. So app.js is just one of the many files that gets sucked in by our build process. Via gulp, which is what we use for our build tool, we can basically scan all the files in our repository, and then through static analysis, build up those dependency trees, right? So imagine this happening for every single file in our repository. That information can then be serialized into JSON, which then becomes a source of truth for looking up information about any module in our repository. So this is what that actually looks like inside. So we mentioned that the registry here is just a JSON file. And you can think of it as a dictionary that's keyed by the name of the file. So here you see that we've got the deps attribute, which we've seen here. But most interestingly is the deps full attribute. And what the deps full is a fully flattened dependency tree for app.js, right? So because we have entries for every file in our repository, what we've done is sort of walk that tree all the way down and flatten the entire list. So what that means is if I ask for app.js, this deps full represents all the possible dependencies that I might need to make it work correctly. Here, again, is the definition for new search. It looks pretty much the same. Astute observers will notice that there's an additional rule attribute here. And we've parsed this out of the annotation that we talked about just earlier. All right, and the last module here is our packager. And this brings together the two previous modules we just saw. You can tell we're pretty creative with our module names right now. So the API is super simple. All you do is simply require up all the things that we've talked about until now, and we feed them to the packager. So you've got your registries, you've got your rules, and you ask the packager for the file that you want, and you simply get a URL back. Let's take a look and see how this is actually working underneath the hood. So the first thing that the packager does is actually go and ask the registry for the definition of the files that we asked for. So in this case, we look up the app.js definition and get that deps full list. Second, we'll determine which of these files have rules associated with them, right? So as we saw earlier, old search and new search is the test that we're doing. So these are the two files that have rules. And next, we'll run these rules. And anything that resolves to a false will simply get filtered out of this list. So let's say this user has been allocated to the new search experience. What will happen is old search gets removed and new search stays in. Now we can actually take this a step further because the registry is smart enough to know that once old search has been removed, we can then further remove any subdependencies that are no longer required by other files. So let's remove those too. So finally what we're left with is all the files that are needed for this specific user in this specific experience. So we'll concatenate those files and serve it out to the user. So that was a lot of information. I think it would be helpful to do a quick recap using visuals here. So at build time, we send our files through our build system. We'll generate these registry files, which are then used by the Node app at runtime. And at request time, when the user comes and asks for a package, we'll ask the registry for that full list, filter out the things we don't need, build the package, send it out. So after all is said and done, it turns out we're actually able to do a bunch of other really neat things with those modules we just saw. So the registry, this was really, really interesting for us. We originally designed it to help us build our dependency trees, but we kind of discovered along the way that we could leverage it to do some really, really interesting things. So in this slide, we're looking at another definition. I've omitted the deps and deps full because we've seen those, but you'll see we've got another one here called deps count. So what we're doing here is really counting for dependencies. So as we walk down that tree, we've counted how many times each of these dependencies have been asked for. And it's great because that allows us to do the runtime removal of those dependencies, but it means we can also do things at build time to basically run through the registry and say, if we don't see any files asking for a specific module, then it means it's probably deprecated and we can prune that. And we've got some other interesting things down here, like a hash attribute and file size. It's kind of useful because what that represents is basically the file size of just the file of this in this definition here, but also the full file size for that entire tree. So if we think our packages are getting too large, we can simply inspect the registry and figure out which modules are the offenders. Similar to JavaScript, we build our CSS modules using the less at import reference directive, and that basically allows us to build up CSS dependency trees as well. Again, another registry definition. This time for CSS, looks fairly the same. You'll notice that we've got an extra CSS attribute here that does counting for number of selectors, declarations, and media queries. So this too, again, is pretty useful for perf analysis. And the best part, well, the registry also caches the contents of all of the files in our repository. I see some of you are probably thinking, crazy town. What are we doing? So the registry concept can actually be extended to all the files in our front-end, all the front-end assets in our repository. We can basically send them all through our build step and create registries for all of them. And if you remember, these registries are pretty much all-inclusive, right? They contain a list of all the files in our repo. They contain the dependency trees for these files. They also contain the metadata that's required to resolve conditional inclusions. And they also contain the full contents of each file, right? So what that means is that these registries alone represent the full and complete UI that's required to serve up any page on the website. So we can think of these registries as a UI bundle, right? So we'll bundle them up and deploy them to the CDN or deploy them to the cloud. And once they're deployed, we can then fetch them from our Node instances. So you're probably wondering why bother deploying to the cloud? What are you getting out of this additional complexity? It means that we can deploy new UI bundles anytime. And we can do this independent of the Node app itself, right? So if we need to push a hotfix that involves changes related only to our templates, our JavaScript, or our CSS, we can do it without redeploying new Node instances. And because these registries are just JSON files, right? We don't even have to restart the server because the UI bundles are just downloaded and read off the file system. It also means that because everything in the UI bundles get cached in runtime memory, throughout the entire course of serving a request out to the user, we never touch the file system. So we don't touch it for templates. We don't touch it for our JavaScript or our CSS packages either. It's really fast. So you're probably wondering at this point then, OK, I want some numbers. This sounds pretty crazy. So if once the conditional dependencies have been resolved for our packages, right, and it's just a matter of writing those files out to the response, it takes on average about less than 5 milliseconds to write out an entire package. So it doesn't matter if it's CSS or JavaScript. It's really, really freaking fast. And the reason for this is because we can selectively decide how we want to cache this stuff in runtime memory. For templates, since they're consumed as strings, we simply cache them as strings. For JavaScript and CSS, since they're not really consumed in the node layer, we can actually store them as buffers. And what that means is that once the package is requested, we can simply pipe them directly to the response. Pretty fast, and it's really simple. So if there's 3 things I want you to take away from this is really, A, leverage the server, right? Just because you can do it in the browser doesn't mean you should, though I'm sure many of us are guilty of that. Second, stack analysis is great. We've leveraged it here to great effect, and you would much rather take that hit, right, at build time than you would at request time. And lastly, divide and conquer with modules, right? Each of these modules that I just shared with you guys, like they're small, specialized, they don't do a lot on their own, but you bring them together and presents a pretty compelling solution to an interesting problem. And lastly, I just kind of want to share some of the learnings that we had as we built out this solution. So maybe I might be preaching to the choir here, but these were learnings that we found to be quite valuable. Learn by doing. So multivariate testing is really complex, especially in the UI. This is our 3rd attempt at asset packaging within Node, and it's still evolving. It's changing to this day. So it will continue to evolve as we add more features. And the thing with just getting out there and doing stuff, like with the registry, for example, is just getting out there and then realizing that we could actually do a lot of interesting things with that. Fail fast and move faster. And I don't mean that in a way that we want to fail that the end user is impacted, but really you want to roll stuff out sooner, figure out what works, what doesn't work, and then iterate quickly on both of those sets. So there's this great quote here from Thomas Edison that says, "I have not failed. I've just found 10,000 ways that won't work." And I think this is really apt for describing our situation, right? The thing you really want to avoid is becoming like an armchair architect or whiteboard architect, right? You're sitting in your business meeting room and you're drawing out 10,000 different designs, but really, ultimately, it's the one that works in practice that wins. And lastly, keep things simple. Keep your module small, break down the complexity into super specialized NPM modules. And that's all I got. So I'm actually here today with a small army of Netflix folks, as you can see. So if you have any questions, feel free to chase us down later today. Thanks.